I guess.
Yeah, we are live now. Okay.
Perfect. Um,
Let me just put him on the spotlight. Okay. Yeah. Okay, we are.
cool. Let's wait for like 1 more minute and then we can start with it.
Yeah, let's
Uh,
start at
Yeah,
1:30.
yeah, of course.
Cool.
Welcome everyone.
Welcome
Uh,
all. Yeah.
this is the last session of the of Nakshatra. Nakshatra, like Ojuswi, just to you, was a 3 day long event. Like we had a festival. We had various sessions and a hackathon that has more than 900 registrations and coding
Oh, nice.
competitions. Yeah, and everything was like wild. And we really wanted to end up with blockchain because it's such trendy topic. And
Yeah.
I like when I got in collaboration with Tezos India, and I
Mhm.
requested them that please give us a speaker who can handle the blockchain and make people know what blockchain etc. is all about. So
Mhm.
yeah, so that's how we got you, and thank you so much for coming here.
No problem. This workshop is also going to be wild.
We expect the same. Okay. Shivendra, you can start.
Yeah, of course. A very warm welcome to all here. Before we begin the session, let's show some excitement in the chat box. Let me know how much you guys know about blockchain and cryptocurrency. Let's see some excitement in the chat box.
Whatever you know, you can type in the chat.
Yeah, yeah, we're getting responses.
A little bit
Yeah, a little
excited,
bit,
a bit.
not much excited.
6 out of 10. Excited.
Well, yeah, yeah, all right. That's great. That's great. So, cheerful greetings to all. I, Shivendra, I am an executive member of MEGDSC and I'm the host for today's session. And I welcome you all on behalf of our entire team at MEGDSC for today's session, CryptoNova. It's a session on crypto and blockchain. And before we dive into this world of blockchain and uncover some interesting concepts, it is my honor to introduce our speaker for today's session, ojuswi rastogi. He is currently working in Tezos as a software development intern, and he's also a blockchain developer. He was also a mentor at Girl Script Summer of Code and much more. Before taking much of your time, I would like our speaker Ojasvi to begin with the session. Thanks.
Hey, thanks for having me here. So we'll be starting with blockchain today, and um, it's not just about cryptocurrency and all. We are going to start with the basics, and we'll cover the things that blockchain can do. All right. So I'll be sharing my screen, and I have a PPT ready, and we'll be going with that.
Yeah, okay, just a second. I'm unsharing this.
Okay,
Okay, now you can share it this way.
just a second. All right. So it should be visible, right?
Yes.
Okay. Just hide this. All right. So let's move ahead. So today we are going to cover in this session the Web3 transition. That's very important because uh, until now we have been using Facebook, YouTube, and Instagram, all these types of traditional web apps. But now we are having a transition in the web technology, which is also called Web3 transition. So we'll just look over that. Then we'll be covering some overview on the blockchain because obviously Web3 is not going to be possible without blockchain. And in order to understand blockchain, you have to get some grasp of some cryptographical concept and all. So first we'll be talking about that, following a bottom-up approach from the cryptography. We'll again come to blockchain and try to connect all the dots, that how does this work. Okay. And then finally we will move to smart contracts, and how to use them, how to develop over them, because smart contracts is the thing which makes it possible to basically get over with cryptocurrencies and make any kind of stuff that you want on a blockchain. And then we'll get our hands dirty and try to have an hands-on approach, and I'll show you how I develop some decentralized application, and you can do it too. So this is the thing that we are going to cover today. All right. So yeah, of course, how can we forget this? So can anyone tell me what this is? Just type in the chat what this thing is. This exact except the lines that are being drawn on the screen. What is this thing? This image. कहाँ चला गया ये? A web page. Cool, that is a web page. Any more insights? I mean, it is a web page. I mean, that's cool, but all right, yeah, that static page. Okay. So yeah, that's the web page, and that is what we were seeing in the starting of the internet, when even before the .com boom and everything. These are the types of websites that were we cannot interact on this page. Yeah, we can interact just on the client side. The client cannot interact with the server. The communication is not two-way, it's just one way, from server to client, from client to you. And you can somehow interact with the client. By client, I mean the browser. So these are the types of websites that we were having in this time period, 1991 to 2004. That's a rough time period, but that was called the Web 1.0. So it was completely static. Okay. There was nothing dynamic. For example, if we take an example of YouTube. So YouTube is dynamic. I mean, I'm literally live on YouTube. So I'm giving my information from here. Then this information go to Zoom. It gets distributed to all your clients, your mobiles and laptops, computers. And then from there, it's from Zoom only it is transmitted to the YouTube servers and it's being liked. So that is Web 2. But at that time, everything was read only. There was no interactivity between clients and yeah, keep asking question. Clients and the server. Okay. So, and it was also centralized. What do I mean by centralized? If you look closely here, there is some website, www.geocities.com. So this website is hosted on a server. That server is linked with the DNS, using the DNS from this domain name. And the complete website is just saved on a single server. The server is like a computer. Okay. So whenever you have to access this website, you make a request to the computer. That computer serves this website to you, and then your browser shows it. So this model was quite efficient at that time. It is still efficient, but there are problems with centralization, and we'll cover over that. And yeah, the file system was static. So you basically have a index.html file that's kept on the server, and it's just statically sent to you, rendered on your browser. So this was Web 1.0. it went for a period of time, and then we transited to Web 2.0 slowly. Now on Web 2.0, as I've already told, that there were two-way communication from your client to the server. It was not just read only, but it was read and write. Okay, so you have some information with your client also. You can send this information to the servers. So this gave up many. This gave us many opportunities to create new ideas. Okay, hence we saw many of the popular tech giants that we currently have, like Google, Facebook, or Meta. So um, these companies were just a product in the starting, and they were offering something which included read and write, and that was only possible because of Web 2. And now they are tech giants. And similarly, we have again started to see a transition which is being happening currently, and that includes reading, writing, and then owning something. Okay, so it gives us a consensus, it gives us transparency, it gives us security, and that is what Web 3 is. So in Web 3, you obviously have that read, right? But then you can write some information onto let's call it a database for now. So you can write some information on that database, and whatever you write on that database, everyone agrees to it. So first of all, it's transparent. Whatever is written on the database, everyone can read that. The second thing is everyone agrees to it. Whatever you have, uh, whatever you are making the change to the database, whenever you make a change on the database, it's called a transaction. So let's say there was some letter written A over there, and then you go and say, all right, I want to change it to B. Then you are making a transaction. Changing the state of the database is called the transaction. So whenever you are making a transaction, everyone agrees to it, everyone around the world. And when everyone agrees to it, then the database is changed. So first of all, you got the transparency. Okay. The second thing is the database is not centralized. There is no single server where, I mean, there is, but not just one server. There's not just one server in the world where the database is stored. The same database is stored on multiple computers throughout the world. So globally, there are thousands of computers, which are also called nodes. And on those nodes, these servers are stored, and these databases are stored. And the whole network of nodes are peer-to-peer connected. So I can host a node in my laptop, and my laptop will connect to other nodes around me, maybe in India, maybe in China, Pakistan, maybe in whole South Asia, and maybe it can directly connect to USA also. So it's like a complete web. All the nodes are peer-to-peer connected, and all the nodes have this database. And all the databases are identical, they are same. So if I need to make a transaction, what will I do? I'll make that change in my database, and I'll broadcast that information to my peers that, okay, listen me up. I have this change to make on the database. I'm making this transaction. You all see it and tell me that, is it okay? Is it okay to do so? And if all of them agrees, so they also transmit this transaction request to their peers also. And when everyone agrees to it, they make that transaction on the database. Okay. I kind of gave you an overview of blockchain. I'll tell you how. So yeah, we are having this kind of a trend. Okay, so initially we were having this much number of websites, and it kept on growing, and now we have researchers which says that the smart contracts are growing with a similar fashion, and this is just this much of the this much if you compare it with the past. So history is kind of repeating itself. The evolution is again taking place, and the next Google, next Facebook are being built right now on Web3. And that is why learning Web3 is so important, because you're getting ready for the future. Okay. So the whole overview that I gave was a blockchain only. This is how it looks. The database that I was talking about is called blockchain. That is blockchain. Blockchain have these many properties. I'll discuss through it. And this is how it looks like. So throughout the world, you have these nodes. They can be laptop, they can be desktop. It depends on what blockchain it is. For example, if we talk about Bitcoin, for Bitcoin, hosting a Bitcoin node on your laptop is uh, no longer useful. It's no longer significant. There are dedicated machines for it, which are also called ASICs, ASIC. So that's because Bitcoin have become too difficult to mine, and your normal GPU or CPU is not enough to mine it. You need very hardwired machine which can do it very fast. So that's why for Bitcoin it's ASIC, but um, other blockchains like other proof of stake or Ethereum also can be mined through your GPU, and that's why it's shown laptops here. And a blockchain looks like a linked list. If you know the data structure linked list, mining. Okay, so mining basically means that I'll explain the structure of the blockchain, and then I'll tell you. So you have these blocks. Okay, just like linked list. When you have a linked list, what do you do when you need to add the data? You put that data into a node and then append that node to the linked list. We do the similar thing with blockchain also, but here are some differences. Okay, the first difference is linked lists are in the primary memory. They are in your RAM. They are stored in your RAM. Whenever you make a linked list, it's in your RAM. Blockchains are not on your primary memory. They are stored in the secondary memory. And since in linked list, we have to keep track of their locations. That's why we link it using the addresses. Okay. But in blockchain, you already know where they are. They are on your secondary memory, just next to your previous block. So you have to maintain the integrity, and to maintain the integrity, you link it using cryptographic hash functions. What are they? We'll cover in the next slides. I'll explain it to you then. So now you were asking that what mining actually means. So when you have these blocks which are linked to each other using hash functions, there is an algorithm called a consensus algorithm. And if you are using the proof of work consensus algorithm, which Bitcoin uses, then you have to mine a block. And what does mining means? In mining, you basically have to solve a cryptographical puzzle. If we go into the depth of it, it basically means you have to find a hash function which comes under a certain range, and basically you have to find a data, any small data, it can be a number, which you put in a block. You already have the data which you want to put in a block. Let's say there's a data like I own some NFT. Okay, this is the data that I put it into the block. Fine. Now mining means that just with this data also, I also need to add some number I don't know what that number is going to be, but I have to make sure that after adding that number, hashing the block, you get a hash value which comes under a certain range. Sometimes it comes, sometimes it not. Okay. And mining basically means that trying brute forcing this algorithm again and again, again and again, until you find that hash which comes under that section. So that is mining, and it's difficult because you again and again have to calculate the hash, and calculating hash, even if it's fast, you are calculating millions of hashes um, in a very short period of time. So you have to do a lot of work, and that is mining. And we'll cover it in the further slides, then you will understand. But for now, we have to know about blockchain. So these are the blocks that are linked together using cryptography. They are transparent because the whole blockchain is with all the nodes. So if you are participating in the blockchain, you in the network, you have the access to the whole blockchain and you can read everything. Okay, so it's transparent. And I'll show you how it looks like. I'll show just a second. So how does a blockchain looks like? This is how it looks like. So here you can see this is a Tezos blockchain explorer. Every blockchain have kind of an explorer. An explorer is like a website where you can real time watch the blockchain. Okay, so this is the Tezos blockchain which is being made. So just you saw the latest block being added into the blockchain. So this is the latest block. This is the latest block number. And since it's transparent, I can literally read all the information that's being added to the blockchain. So in the latest block, we got these many transactions. All of these are transactions which are being added to the block. These are some of the header data of the block. That this was the where was it? This was the number. This is the hash of the block. This was a timestamp. At this time, the block is mined. All of that header information, and then we got the transaction that okay, someone sent some test to some other person, like this contract sent this many tests to this address. So these are the transactions which are all of them are applied. They are put into the block, and that block was added to the blockchain. And when everyone agrees to it, it eventually comes to this website also. So that is how it's all transparent. Okay, you can see everything on the blockchain. It's decentralized. Since the blockchain lives on all of the nodes, no single node is having the total control over it. For example, if I talk about the YouTube servers, if I upload a video to the YouTube, the YouTube have more power over my video than me, right? They can take down the video without my permission, even if I made that video. So that is because the platform is completely centralized. Their server have all the power. Google have all the power on YouTube, and Sundar Pichai have all the power on Google. So that's how it's centralized. Okay. Blockchains are decentralized. There's no single entity which controls the network. Not even the person who created it. So Satoshi Nakamoto created Bitcoin, but he does not control it. The Bitcoin network started, and it's not going to end. No one will take down until the whole world agrees to taking it down. It will always be running. So that's the power of decentralization. Whatever comes onto the blockchain, it will never go off. It will never get down. So I'll show you an example of decentralization also. Here's the hash rate distribution of Bitcoin. So these are the pools Pools are basically when multiple nodes work together to mine block. So let's say if a block is mined, then that will be said that the whole group of those nodes try to mine the block. Okay, so these are the pools, and as you can see, the whole hash rate basically means the more hash rate you have, the more power you will be having. So the whole Bitcoin network have some hash rate, and this power is distributed among all of us. So these are the big, massive pools of the world. But again, a very large portion of Bitcoin is mined from unknown people. They work alone. They try to mine alone. Sometimes they also get successful also. When they successfully mine it, they get the reward, they get some Bitcoins. And this is how you can see that there's no single person who can have all the power over this network. So blockchains are the best decentralized technology. Okay. So decentralized also means that there is no government or anything which controls it, and that's why I think they hate it, because they can't control it. No one can control any decentralized uh, blockchain. And then they are immutable. So whatever is written on the blockchain, it's always there. If I wrote on the blockchain that I own that NFT, that will be always written in this block, in the fourth block on this node, in the fourth block of this node, in the fourth block of this node. And now this node is never going to be destroyed, because always new nodes kept on adding, but the new blocks kept on adding. But the blocks that are already added never get destroyed. They are always there. And so distributed ledger. So this ledger is distributed. Everything is distributed. Okay. Secure, as you obviously it's secure, because how do you attack it? How do you hack it? If you try to attack one node, that will go down. No problem. There are 1,000 other nodes, and there's a consensus protocol working beneath it. So for Bitcoin, that's proof of work. Mining comes under proof of work only. And consensus algorithm is responsible for various other things. We'll look into that in the further slides. And it's trustless. Yeah, that's quite an important point. So the way it works is the nodes are connected globally across the internet, peer-to-peer, but they don't know each other. So if I host a node on my laptop will be connected to all the other nodes around the globe, and I don't know them. And even if I don't know them, the blockchain can still work. I don't know them. I don't trust them, hence, because I don't know them, so how will I trust them? And then also the complete network can work. And it has been working for more than a decade or so. So these are the property of blockchain. Okay. And to understand a little more into depth, we have to look at some cryptographical basic concepts. So we'll now jump into that, and then we'll again come on to blockchain, and things will finally make sense. Okay, but not on the next slide, next to the next slide. So the first thing is hash functions. Okay, I already told about hash functions, but if you don't know that, then it probably won't have make any sense. So hash functions are basically like a normal function. Okay, what is a function? A function is kind of a mathematical algorithm which takes an input and gives me an output. That's the function. Okay, I can create a function of adding 2. So whatever number you give, let's say you gave me 49, I'll say 51. You gave me -2, I'll say 0. That's the function. Okay. Now, hash function is also a function, but it follows some properties. Okay, and we'll look into those properties. And I'll show that practically. So there are many hash functions which are being used in the industry right now. They are standardized. Okay, there are many hash functions which are made a standard, and the same hash function you will see being used on many different places. So can anyone tell me some of the hash functions? If there's anyone who knows, just type it in the chat. Any of the hash functions, come on, these are the simple things. No one? Oh God. No one knows any of the single hash function. Okay. So the most the hash function that I've seen being used in most of the cases is SHA-256. It's also known as secure hashing algorithm 256. Okay. So it simply what does this simply do? I'll give an input and I'll get an output. Right, that's the job of the function. So let's say I give some input, and this is the output that I'm getting. Okay. Now the first property says that whatever input I give, I'll always get a fixed size output. So I'll always get an output of 64 hexadecimal numbers. Okay, hexadecimal characters. Okay, so whatever input I give, so let's say even if I give a small full stop, it will probably be not visible onto your screen. Let's say I add a. Okay, so if you apply SHA-256 on a, you'll get an output. If I give a very large input, let's say I copy the whole chat, somewhat of a chat. So now I'm giving some good amount of data as an input, but I still give the same fixed output. Not same, but same size, fixed size output. So that's the first property of hash function, that output, the size of the output is always same. Okay. No matter what input you give. So I can even give the input of terabytes. Okay, zettabytes. I can give as big input as I want, but I'll always get a fixed size output, and any hexadecimal 64 character string in case of SHA-256. Even the empty string is giving me some hash. So that's the first property. Second property is one-way trip. So hash functions have a very nice quality, and that is they are always one way. So for example, the example that I gave you, adding 2, that function is reversible. So if I ask you that I'm giving you an output, and what should be the input to form that output in case of my function. So let's say I give you 2. So you can reverse calculate it. I've made a function of adding 2, you will reverse it, you will subtract 2, and you will say, okay, 0 is the input that will give me 2. And you can compute it inversely. Okay. But hash functions are designed in such a way that you cannot reverse it. So you can only get an output from the input, but you cannot get or even predict the input from an already given output. So if I write some string and get some hash of it, and this is the hash which I gave to my friend, and I say him that this is the hash, just just try to guess the input, or you can even calculate it any way you want and try to give me some string, which if applied an SHA-256 algorithm, then that should give me this hash. And there is no way they can calculate it, okay? Because their SHA-256 or other hash functions are made in such a way that you cannot reverse calculate it. And this is the crux of the security. This is like, if someone manages to kind of get through this algorithm and successfully reverse calculate, then so many things in this world will collapse, because only this mathematical algorithm is saving all of that. And it's mathematically proven that it's practically impossible to do that. You can only just brute force. You can keep on trying different input and get output again and again, and kind of hope that it will give you the desired output. That's the only way to do it, which will take probably more than the lifetime of this universe. So it's practically impossible. Third property is they are deterministic. So determinism, okay. By deterministic, it means that whatever input I type, let's say I type my name. So when we hash this string, we get an hash value. This is the hash value. And whenever I try to hash the string, the same string, I'll again get the same hash value. It's not going to happen that I give some input string and that it gives me some hash, let's say 123 is the hash, and then sometime again in the future I again give the same input string, and the next time I give some I get some any different hash value. So maybe it's 456 or any other value. So that's not going to happen. If you are using the same hash function on the same input, you'll always get the same output. They are fast to compute. Obviously, for small inputs, it's like constant time algorithm. It computes almost instantly. It shows avalanche effect. So by avalanche effect, I mean that, let's say I give a very large input to it. So it's a very large input, okay. And even if I change just the last letter of it, so last letter is S. If I type something else instead of S there, let's say I type C, the whole hash will change. It's not like I'm just modifying the last part of the data, input data. So maybe the last part of the output will also get changed. That doesn't happen. The whole output gets changed. So it's like impossible to even predict that what you're going to get. See, the whole output is changing. That's one more property, and then they are collision free. So a good hash function have a very less probability of collisions. What are collisions? Okay, I'll tell you. So let's say I give an input, I get a hash value of it, let's say 123, and then I give some other input which is different, and then I'm also getting the same output. So for different input, I'm getting the same output, 123. There's some name ojuswi, I'm getting 123. There's some name rastogi, I'm also getting 123. Even though the input string are different, but the output is same. So that is collision. And a good hash function have probabilistically 0 collisions. So there should be almost no collision. And in case of SHA-256 also, the probability of collisions is very, very less. So these are the hash functions. Are there any questions in hashes? In the beginning, no one knew what are hash functions. Now, do you know it? Yes. Cool. Yes. That's good. That's good. So these are the first thing which are very important uh, in blockchain also. Like Bitcoin also uses SHA 256 only. And if anyone anyhow somehow manages to break through SHA 256, not only just the whole Bitcoin system will collapse, the whole world will like panic and start to find some different alternatives, because SHA 256 is being used in many places. Okay, your passwords are made secure through it. Your Wi-Fi password is made secure through it. Uh, Anything you can imagine, most of the secure things are probably using some hashes one way or the other. Second thing is uh, moving to the second prerequisite, which is encryption and decryption. So that's one more cryptographical concept which is used for security, and it comes in the category of encoding. So let's say you have some information, you want to send that information to your friends, but uh, you don't want anyone else in between to understand it. Okay, so I'll give you an example. I'll show you directly show you the example, and that way you will be able to understand them. Okay, so let's say I want to give some message to my friend, and my friend is someone amongst you only. Okay, just a second. 2:30. We can let me just see, just a second. Okay, so okay, then let's do one thing. We will start with the development on blockchain. I'll show you how blockchain looks like, okay, and how we work on blockchain. Fine. So first I'll show you some of the examples of any blockchain app. All right. So let's try. What can we try? Some NFT marketplace. Let's say Calamint. So it's an NFT marketplace. You guys know what is an NFT? Anyone? What is an NFT? That's cool. Cool. So NFTs are basically some digital asset. Okay, it can be anything digital, non-fungible token. That's great. So they are kind of a token. Okay, NFTs are basically you have some digital asset and you can own it. So for example, I have non-tangible fund tokens. Mm, no, no, it's non-fungible token. I'll tell you how it works. So you have these, yeah, you have these assets and you can own them. I'll tell you with an example. So a few months ago, I participated in a hackathon. Okay, and generally, what happens when you participate in a hackathon, they give you a certificate, and you get that certificate through email or something. So it's mostly a PDF or a JPG or some image. They send you through the email through attaching, and that's it. That's the way you get certificates. But the thing is, I can fake it very easily. For example, if I want to show that certificate to anyone else, I can, and I haven't participated in the hackathon, then I can simply fake that certificate. I can make some very similar looking copy of it, write my name on it, Photoshop or something, and then I can show it to the people. And people don't have, they can't verify it. How they verify it? So when I participated in that hackathon, that was a blockchain development hackathon, TES Asia. So I got the certificate as an NFT. Now, the property of NFT is that that certificate was written on the blockchain, and when you write that information on the blockchain, against that information was written my address. First of all, where is this NFT going to go? The owner is me, and who made that certificate. So that certificate was made by the people who conducted that hackathon. So now this information is written on the blockchain only. And now I got the NFT of that. But when I say that I got the NFT of the certificate, that basically means that on blockchain, against my address, some asset is written. That is just the basic meaning when you say that I own an NFT. So a wallet owns an NFT, and wallet address is written just next to the asset. So now when it's written on the blockchain, I can easily prove it. Now you can go to anyone and say, see, this is the address, and you can look onto the blockchain that this certificate is written right besides my name. And it's also written that who minted it, who made this NFT. And that's the address of the people who conducted the hackathon. And hence it's verifiable. So I can just send that NFT, not send, but share the link of that NFT to anyone, and they can easily verify that. So that's the point of NFT. You can prove the ownership, and that is done through blockchain. So how does that all happen? How do you write information on the blockchain? I'll show you that. So just a second. So these are all the NFTs, fine. And let's say I want to check some cool arts. This monkey looks cool, so I can go to it. And here you can see this is a token ID of it, which are unique to everyone. And see, here it is. This is the creator. This information is being fetched from the blockchain only. So all of these things are written on the blockchain, and it's not going to change anyway. So this is the creator, and same is the owner currently, and there's only one edition of this NFT. Its symbol, it comes in this collection. This is the price of it. So you can on a marketplace, you can buy and sell NFTs. So I can create an NFT, and then if I can I can make a program for it on a kind of a code on blockchain, which can self-execute. So I can code it in such a way that initially this NFT will be written against my name, but if someone transfers me this much amount of tokens, then this NFT's name will be replaced by that person. So this is a kind of a logic. That's a program which is written. Okay. And these type of programs are called smart contracts. So as a blockchain developer, you basically make smart contracts. Smart contracts are the code which are deployed on the blockchain, and then people can use it. So all this information is written on a blockchain in a smart contract only. And when someone will transfer this much amount of TES, which is the cryptocurrency of Tezos, when someone will transfer this much amount of TES, then this NFT will be transferred to that person. And people are ready to pay even more because they want this NFT. So if there's a person A who wants it, okay, I'll give one TES and give me this NFT, then there's a person B also who wants to give more money to get this NFT. And that is how the person who originally created it is making. And this NFT is being transferred from different people to different people, you can see here. And I can even look that on the Explorer also that I just showed you earlier. So all of that can be made on the Tezos blockchain. This whole project is on Tezos blockchain, and I'll show you how to create that. So not just an NFT marketplace, whenever you want to make any kind of decentralized application, there are many applications which are currently being built, many DeFi applications, decentralized finance application, where you can exchange different tokens. You can, for example, there's TES. There is also one cryptocurrency on Tezos blockchain called Kalam, KALAM, for Kalam token. So you can exchange different token. You can exchange Kalam token from TES, or you can exchange TES from Kalam. So that's one more application. And many of these applications, which are also called dApps, are very simple. You just make a smart contract, you deploy onto the blockchain, and then you create a kind of a front end, very simple front end using React or something, and you link that front end to the blockchain. That's it. For example, here I am. What I will do is I'll simply connect my wallet. So in order to use decentralized application, you need wallet. So this is a Temple wallet, which is used for Tezos blockchain. And currently I don't have any tokens in it. And I can even show you my NFT in this wallet with me. Let me show you. Collectibles. My main account. See, here it is. Tez Asia Hackathon certificate. So this is an NFT. Okay. This is an NFT. This is the address of this NFT, and this is the ID of this NFT. And I can even search up this address to the what I got something else also. So I was go someone sent me this NFT, I guess. So yeah, your public address, whoever have this public address, they can send you meme NFTs also. So I guess I just realized I got an NFT also. Again.
Sorry to interrupt you. We have a question from the audience.
Yeah, sure.
How is NFT different from cryptocurrency or any other digital currency?
Okay, so that's where fungible terms differentiated. Uh, Let me explain what fungible means. So there are two types of token when you talk about tokens in blockchain world. The first type of tokens are fungible tokens, and then comes the non-fungible tokens. By fungible tokens, I mean like TES, okay, or Bitcoin. So fungible, I can also give you the example of rupees also in fungibility. So let's say I have 10 coins of 1 rupee, and you have just a single note of 10 rupee. So we can exchange them. That's called fungibility. That means even if they looks different, they have the same value. The whole world agrees to it. That is why they have the same value. So that is fungibility. You can exchange them. When it comes to non-fungible things, let's say I have this phone. Okay. Now, my friend can also have exact same model of this phone, bought on the exact same date, but still I cannot exchange my phone with his phone, because both of our phones are non-fungible. they have different values. Similarly, I can have same car and that person can also have same car, but we cannot exchange them. So that those are the types of tokens which are non-fungible. So for example, here also we got that monkey, and you can also have some other monkey. Now that monkeys will be having some different property, maybe some different skin color or some different hair colors. So hair, monkeys have hair. We have clothes, but monkeys have hair. So they can look different, and that's why their value is also different, and that's why you cannot just exchange them. So that's the difference. Uh, is that clear? So I'll just quickly, in the meanwhile time, I'll just quickly show you how you can develop smart contracts, which is a part of a decentralized application on Tezos blockchain. And the most popular way to do it using SmartPy. So SmartPy is basically a very simple integrated development environment in your in this browser only. So you can just simply go to the editor and start making smart contracts on it. You make smart contracts, you deploy it on the blockchain, then you make a front end, you connect it with that smart contract, and that's it. You just made a DApp, decentralized application. So is your doubt clear about NFTs and digital currencies?
Yeah, I think it's clear.
Thank you. One more thing, if NFTs can't be exchanged, how it generates capital to people investing in NFTs? There is much hype in market on this. They NFTs can't be exchanged. Okay, you got confused about exchanging. So NFT cannot be exchanged by NFT. Like for example, you have an NFT of monkey, I have an NFT of some dog. So we cannot exchange those two NFT. But what we can do is we can exchange it with some fungible token. So let's say you have the NFT of monkey. I will give you, let's say uh, five TES in exchange of that monkey. And similarly, you can get probably two TES in exchange of my dog. So that is how you can exchange NFT. So mostly what people do is they buy some NFT for some amount of cryptocurrency, some amount of fungible token, and then sell the same NFT for some higher amount of cryptocurrency tokens. And that is how they make capital. By investing in NFT, you basically mean that you are giving some crypto to own an NFT and then expecting to sell the same NFT in some more tokens. And that is how you'll make profit. Is blockchain NFT not good for environment as it consumes a lot of energy? Good question. So there are many blockchains which uses a consensus protocol known as proof of work. For example, Ethereum. Most of the NFTs you see today are Ethereum based or are made on Ethereum. And Ethereum uses proof of work. And the thing which uses so much electricity is proof of work. So if there's a blockchain who is using proof of work consensus protocol, then that blockchain is going to consume a lot of energy. Bitcoin is the biggest example of it. Ethereum is also a very big example of it. So it's and that is why it's not environment friendly. It's very much its carbon footprint is so much that it's comparable to even countries. Like Bitcoin comes in between of Argentina and Switzerland. It consumes that much amount of electricity. So it's good. So what's good is you should use the blockchains which don't use proof of work, which use some better alternative. For example, proof of stake. So Tezos blockchain uses proof of stake only. So the NFT marketplace you see here are completely eco-friendly. Like Tezos blockchain is the most eco-friendly blockchain in the world today. Its carbon footprint is like insignificant as compared to Bitcoin or Ethereum. So you can go with NFTs and tokens if you are using any eco-friendly blockchain, and there will be no harm with that, because proof of stake doesn't requires you to consume this much of an amount of electricity. Proof of stake and success algorithm can work without electricity also, not without, but with very less electricity also. So here's SmartPy. These are the what is this? This is some smart contract that I wrote sometime.